The Amiga service and repair video was designed to help you, the Amiga owner, get a better understanding of how the hardware inside the Amiga computer works, and then apply this information toward performing basic repairs. Most failures in the Amiga are the result of a failure of one of the many socketed integrated circuits. The key is to isolate the defective chip. Before we begin, there are a few very important points of interest. Number 1. If your computer is less than 1 year old, it may still be covered under the original manufacturer's warranty. If you attempt any service or upgrades, you will void your warranty. For warranty repair, contact your local Amiga Service Center or Commodore Express. Number 2. The Amiga uses many CMOS-type integrated circuits in its construction. These devices are very sensitive to static electricity. Static discharges at levels much lower than you can feel can result in erratic operation, shorten lifespan, or even cause a total failure of the device. The best defense is to observe proper static handling precautions anytime you are working on your computer. Place the circuit board you are working on an anti-static mat and use a grounding wristband to ground your body to the circuit board. Also try to wear clothing that is less likely to produce a static charge. Number 3. The Amiga contains many integrated circuits which have been soldered directly to the motherboard. Removing these ICs involves skills which require many years of training and experience to perform properly. Attempting to remove these integrated circuits without the proper training could result in a circuit board that goes beyond economical repair. We strongly recommend that unless you have training in this area that you do not attempt to remove these integrated circuits. This video is geared toward performing repairs involving the socketed chips only. Later on, we will tell you about an inexpensive solution to the soldering problem. Number 4. The power supplies used in the Amiga series computer are switching type units. High voltages in excess of 300 volts are present. All of these voltages are properly shielded by the covers of the power supply. Making contact with one of these voltages would at best make you jump about 10 feet in the air, and at worst they could be fatal. These units are extremely hazardous and repairs should not be attempted except by qualified personnel. Being prepared with correct tools and equipment is the most important factor in successfully getting your computer back up and running. Most service shops have a complete stock of parts as well as a functioning test system. While the majority of us cannot afford to have a second computer around just to help fix a broken machine, having a spare set of integrated circuits can be invaluable. Several companies offer spare parts kits at very reasonable costs. Any parts kit should include the following parts: 2 8520 complex interface adapters, the 8370 or 8372 Fat Agnes chip, the 8372 is the chip that gives you 1 megabyte of chip RAM, an 8362 Denise chip, an 8364 Paula chip, a 1.2, 1.3, or 2.0 ROM, a 68000 microprocessor, a 5719 Gary chip, and if you own the Amiga 2000, a 318075-02 Buster chip. Recommended tools include a Phillips screwdriver, a number 10 Torax driver, which is used to remove the case screws on the Amiga 500, a 5mm nut driver, which is used to remove the nuts located on the various ports, a flat-tip screwdriver, a precision screwdriver, Phillips type, a set of needle nose pliers, a logic probe, a digital voltmeter, a bottle of isopropyl alcohol, cotton swabs, the anti-static mat and wristband, an Agnes chip remover, and a standard dip chip remover. Other items which would be helpful include a 20 megahertz or greater oscilloscope, analog or digital alignment disc, alignment test software, and port test software. Another item which you may find useful is a service manual for your model computer. This, however, is not a necessary item since a complete circuit diagram is located in the back of your user's manual. In our discussion of troubleshooting the Amiga motherboards, we will concentrate on problems that relate to the socketed integrated circuits. We will at times refer to some possible solder components which may relate to that particular problem. If you are confident enough in your soldering skills, you may want to attempt to repair the problem. Remember, though, that it is very easy to ruin your circuit board through improper soldering. It is a good time to take out your anti-static mat and lay it down in your work area. Besides being ready for the circuit board, it provides a soft cushion that won't scratch up the case. Turn the computer over so that it's upside down on the anti-static mat. The Amiga 500 case is held on by 6 thorax head screws located along the front and the back side of the computer. Remove the screws with the thorax driver and place them in a small container such as a jar. Turn the computer right side up and gently remove the top case. You will notice some resistance. There are several plastic retainers which hold the case in place that snap in and out. Now, with the top case removed, you can see the disk drive and keyboard assemblies. The next step is to remove the keyboard. First, remove the small grounding strap attached to the disk drive. Next, remove the data connector from the motherboard. Now simply lift the keyboard up and to the back. With the keyboard removed, you will see the 4 thorax screws holding the shield in place. Remove these screws and straighten the 4 retaining tabs. Now gently lift the metal shield out. With the shielding removed, you now have access to all the socketed integrated circuits. It is a good time to attach the grounding wrist strap. If you need to remove the disk drive, first remove the 4-pin power cable and remember its orientation. Next, the 34-pin data cable. Make sure to make a note which end the red stripe is on. Now, turn the computer upside down and remove the 3 Phillips head screws at the locations shown. Now, turn the computer right side up and loosen the screw at the side of the drive. The drive will now lift out of the case. To completely remove the main circuit board, pull back on the little plastic retainer located at the front of the board and lift up and then forward, making sure to allow the ports to clear the back of the case. To put the computer back together, reverse the procedure. When you replace the drive, be sure to reconnect the wires in the correct orientation. Be very careful. Connecting the power supply cable on the disk drive backwards can destroy the drive assembly, while the data cable, if put on backwards, will erase any disk that happens to be in the drive at that time. A good indication that the data cable is on backwards is that the drive activity light will come on and stay on. On the Amiga 2000, remove the 5 Phillips head type screws that hold the case in place. There are 2 on each side and 1 on the back. Once you remove the screws, Slide the case forward while raising the back end of it. Be very careful of wires catching on the tabs of the case. Once the case has been removed, you have access to the inner workings of the computer. On the right side are the card slots. On the left side is the power supply subchassis. The subchassis is held in place by 7 Phillips head screws, 3 on the front and 4 on the back. Remove the screws. Then disconnect the power supply and disk drive data cables. If a hard disk is installed, those cables may need to be disconnected also. Now you can lift the power supply subchassis out. You now have access to the Amiga 2000 motherboard. Preventative maintenance is the first line of defense toward keeping your computer in top operating condition. The disk drives, keyboard, mouse, power supply, and circuit board can collect dirt, which may result in substandard operation. Routine cleaning can prevent many problems from occurring. Let's start with the mouse. The mouse converts its motion into electrical pulses, which the computer interprets as up, down, right, or left. This is accomplished by a set of rollers. Each roller has a wheel with a series of holes which allow light to pass from a small LED to a phototransistor. As the mouse moves, the ball transfers motion to the rollers, causing the wheels to spin. This spinning interrupts the light source reaching the phototransistor. This results in an electrical pulse. Each pulse moves the mouse pointer a set distance based on the direction of the mouse. The most common problem is the dirt accumulates on the rollers, which results in erratic operation. To clean the mouse, first turn the mouse upside down and remove the small cover located directly over the mouse ball. Now place the palm of your hand over the opening and turn the mouse right side up. The mouse ball will fall out, exposing the rollers. Now take a cotton swab with a small amount of alcohol and gently swab the roller while rotating it. Continue until all the dirt is cleaned off. Then use a dry swab to remove any excess alcohol. Take a lint-free cloth with a little alcohol and clean the mouse ball. Then place the mouse ball back in its opening and replace the cover. On some older versions of the mouse, the rollers can actually pop out. To fix them, remove the top cover of the mouse by removing the 2 screws. Locate the popped roller and gently press it back into place. Great care must be taken because the little plastic retainers can break very easily. If they do, you will have to replace the mouse. Cleaning the keyboard is pretty straightforward. Use a damp cloth and wipe the dust off. You can use compressed air to blow anything that might be caught between the keys, but do not spray any cleaners into the keyboard. This will only serve to cause more problems. Also, do not use any solvent-based cleaners except those designed for use on plastics. Many solvent-type cleaners will actually dissolve the plastic. Use the same procedure to clean the exterior case parts of the computer. Also, dust off the interior circuit cards and power supply with compressed air. Remember to always observe anti-static safeguards anytime you work inside your machine. The computer's disk drives require periodic cleaning. You will find several different types of disk drives. Functionally, these drives are identical, the main difference being the manufacturer. The most common drive is the Shannon model FB354, which we will use for our demonstration. The first step is to remove the drive from the computer. After the drive has been removed, it is necessary to remove the front panel if the unit came out of a 2000. With the drive sitting on its side, gently press on the plastic retainer located at the front panel of the drive. and pull the cover about 1/16 of an inch forward. Be careful not to pull too hard or force the cover. The plastic can break very easily. Now take the drive over on its other side and press on the other plastic retainer and gently pull the cover off. Do not use excessive force. The next step is to remove the metal cover. To do this, remove the 3 screws with the precision Phillips screwdriver. Now you can slide the drive assembly out of the metal case. Inside you will see the read-write head and stepper motor assemblies. Great care should be taken while cleaning the heads. They are supported by a fine metal frame, which can be very easily bent. If it is bent, the drive will have to be replaced. A common problem with the floppy disk drive is when a disk is inserted or removed incorrectly, a section of the disk will catch the upper read-write head and bend the metal support. Be sure to check the heads very carefully. Clean the drive with a cotton swab and alcohol, being careful not to bend the metal support. Since we have the drive opened up, let's talk about how to align the drive. While the drives in this computer rarely require alignment, it is a good idea to know how this procedure is performed. The disk drive alignment consists of the speed and track alignment. Several commercial software packages utilizing digital techniques are available. The software presents a representation of the relative head position on the computer screen. However, the most accurate method is to use an analog alignment disc and an oscilloscope. Regardless of which indicator is used, the procedure is the same. The speed calibration is accomplished using the software speed checker. On the bottom of the FB354 drive is the speed control. This adjustment should be set for 300 RPM. Once the drive speed is set, it is time to do the track alignment. On the back of the drive, you will see the stepper motor. The stepper motor is what moves the read-write head. It is mounted using 2 screws. Loosening these screws allows the stepper motor to be rotated. This rotation will move the head back and forth a small fraction of the track width. The goal is to position the head right over a calibrated track on the alignment disc. Using the oscilloscope to view the analog signal off of the read-write head while moving the stepper motor, you can see the effect on the oscilloscope screen. When the 2 lobes of the cat's eye pattern are equal in size, the head is in the correct position. Using the software method, adjust the stepper motor until the software indicates that the alignment is correct. Once correct, tighten down the stepper motor mounting screws and the alignment is complete. Now you can put the covers back on the drive assembly and reinstall it back in your computer. Remember, many problems can be solved or even avoided with the correct preventative maintenance program. However, some problems require a more in-depth look. In our next section, we will discuss how the Amiga hardware works. A basic understanding of how the hardware operates is essential to determining a problem in the system. In this next section, we will cover the basics of the hardware and what they mean to the repair of the computer. The computer is based around the 68,000 family of microprocessors. It is enhanced with the incorporation of the custom coprocessor chipset consisting of Agnes, Denise, and Paula. The system is divided into 2 sections, the main CPU bus and the coprocessor bus. On the standard Amiga 500 and 2000, the CPU buses, or fast bus, run at 7.14 MHz. The 68,000 CPU, Kickstart ROM, 8520 integrated circuit, and expansion cards all reside on the main CPU buses. The custom chip bus is separated from the CPU bus by buffer integrated circuits and runs at 3.54 MHz. The Agnes, Paula, Denise, and 1 MB of chip RAM all reside on this bus. The custom integrated circuits each perform specific tasks in the system. The Agnes chip is the most complex. It generates system clocks from the main 28 MHz oscillator, controls other custom integrated circuits, provides DRAM refresh and address generation for the chip RAM, contains the bit splitter, and controls the 25 DMA channels. The Denise chip is a display chip, and it also interfaces with the mouse port. The Paula chip provides 4 voices of sound to the stereo output, handles serial input-output, provides data read-write to the floppy drives, and processes the interrupts for the 68,000 CPU. The Gary chip provides all the bus control signals, address decoding, and floppy disk control. And last but not least, the 8520 complex interface adapters provide keyboard input, floppy disk control, serial handshaking, printer port, and the ROM overlay signal. By understanding each of the integrated circuit's functions, you can quickly track down which chip is bad. Before we start on the troubleshooting section, let's talk about how to properly remove IC integrated circuits from their sockets. Great care should be taken when removing or installing these integrated circuits. To remove the Fat Agnes chip, it is necessary to use the special tool designed for that purpose. Do not try to pry the chip out of the socket. We have repaired many motherboards with the only problem being a damaged Agnes socket. The rest of the integrated circuits are regular dip-type integrated circuits. To remove these, it is best to use a chip puller. You can also use a small flat-tip screwdriver. But great care should be taken not to pry against the printed circuit board. You can damage the circuit runs located under the chip. To remove it, carefully lift one side of the chip, then the other, gently rocking the chip out. Be careful not to bend the pins of the IC. If you bend them, straighten them out with a needle nose plier before reinserting the chip. Be aware that sometimes a pin will be bent under the body of a chip. And always observe anti-static precautions while handling these integrated circuits. Counting the pins of the integrated circuits can sometimes be confusing. For standard DIP integrated circuits, when looking at them from the top, number 1 can be identified by locating the small notch. The pin to the left of the notch is pin number 1. By counting down this side and then up the other side, or counterclockwise, any pin can be identified. Here is a typical 14-pin chip. Count the pins on this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. The same holds true for larger integrated circuits, such as the 68,000 CPU, which has 64 pins. The Fat Agnes chip is an 84-pin PCLL type chip. Pin 1 is identified by a small dot. You count the pins the same way. The first step in troubleshooting a problem is to observe how the computer reacts when it is turned on. These power on symptoms can quickly isolate certain defects. When the Amiga is first turned on, it runs through a series of power on diagnostics. These diagnostics check the basic hardware. If an error occurs, the power LED flashes and the screen turns a certain color. The color codes are as follows. A red screen indicates that the Kickstart ROM is defective. A yellow screen indicates the 68,000 exception has occurred. Any chip could be at fault, but the 68,000 is a good place to start. A green screen indicates a fat Agnes or chip RAM problem. In many cases, simply reseating the Agnes chip will correct this problem. For a 1 megabyte machine, there are as many as 32 RAM integrated circuits on the motherboard, all of which are soldered. A blue screen indicates a fault in one of the custom IC registers. You could try Agnes, Paula, or Denise. Those are basically the color code problems. If the screen remains dark and no color is displayed, that indicates a problem in one of the following areas: the power supply, reset circuits, the CPU halt line, the clock circuit, or the overlay signal. Before we go any further, you should remember that any signals which are not present may or may not be the result of the failure of that particular chip. Always remember that computer signals are interdependent on each other, and that the failure of any chip could conceivably cause these signals to be gone. Our recommendations are the most likely thing that could be bad. However, you should check other components when you get a failure. Now let's start with the power supplies. The 5-volt power supply is the main power supply for the logic integrated circuits. It is the symbol VCC. VCC can be found at many points on the main PCB. Now we're going to check for it at pin 14 on the 68000 CPU. Using a voltmeter set to read DC volts from 1 to 15 volts, connect the negative or black probe to the common or ground of the computer. We will use the metal shield as our ground point. Now connect the red or positive probe to pin 14 of the 68000. The voltage should be approximately 5 volts. Now move the probe, the red probe, to pin 14 of the 1488 IC. This would be U38 on the Amiga 500 or U304 on the Amiga 2000. The meter should indicate plus 12 volts. Now check pin 1 on the 1488. The meter should indicate a negative 12 volt signal. If these voltages are not correct, look for a possible bad power supply or a short on the PCB assembly. It is also a good idea to check for power supplies at other locations on the motherboard. The diagram in the back of the owner's manual can be helpful. Be aware that some newer revision boards may not match exactly. Once the power supplies have been verified, the reset should be checked. The following checks require the use of a logic probe. Using the logic probe requires a basic understanding of how to interpret logic states. In the digital world of computers, there are 2 logic states. A high logic state is one in which the signal you are testing is at the 5-volt level. A low logic state is at the 0-volt level. Many logic probes have small LEDs to indicate the logic state. To use the logic probe, you must first connect the probe to the plus 5-volt power source on the Amiga motherboard. To do this, first turn the power off to the computer. Then locate one of the TTL logic integrated circuits. This would be one of the small 14-pin type chips. Connect the positive clip of the logic probe to pin number 14 of that chip. Now connect the negative clip of the probe to pin 7. Be very careful not to allow the clips to touch the pins next to them. The 68000 CPU reset is found on pin 18 of the 68000 IC. Touch the probe to pin 18 on the 68000, then turn the computer power on. The probe should indicate a low going high after about 1/3 of a second. If the line stays low, most likely the reset circuit is defective. The 68000 or Gary chip are the main socketed integrated circuits which would be at fault. A check of the schematic shows the Amiga 500 reset circuits consist of U42, R711, R712, C711, C712, C713, and Q711. On the Amiga 2000, they would be U805, R805, RP802, and C813 through 815. The keyboard also generates a reset. To isolate the keyboard, simply remove it. If the reset works, with the power still on, move the probe down one pin to pin 17. This is the microprocessor halt line. It should be at a high state. If it is low, this is an indication of a processor fault. Again, try changing the 68000 or the Gary chip. The 7.14 megahertz CPU clock is input on pin 15 of the 68000. The logic probe should flash at the presence of an active signal. Check the signal with the probe. If the clock is not there, check the Fat Agnes chip. Most logic probes indicate an active signal by flashing back and forth between the LEDs. The system clocks are generated from two possible sources. In normal operation, with the internal clock, the signals are generated by the crystal oscillator X1. The 28 megahertz signal is fed to the Fat Agnes chip at pin number 34. Use the probe or an oscilloscope to check for a signal at this pin. In the external mode of operation, an external clock is generated by a Genlock device and fed to pin 35 of the Agnes chip. The Genlock device sets pin 36 of the Agnes chip to a low state when it is sending a clock signal. Check pin 36 of the Agnes chip. If it is low and no Genlock is installed, this indicates a problem on the motherboard. Pin 2 of the video slot is where this signal comes from. The Agnes chip divides the 28 megahertz clock into the various clocks used by the computer. If you look at pin 37 and 38 of the Agnes chip with the logic probe, you should see pulsing action. If you have an oscilloscope, use the oscilloscope to view the signal. It should be a 7.14 megahertz signal. Pin 39 and pin 40 of the Agnes chip produce a 3.54 megahertz signal. Again, using the logic probe, check for activity on all of these lines. U33 in the Amiga 500 and U107 in the Amiga 2000 buffer these clock signals for other areas. Use your logic probe to check that the signal is making it through these chips. A check of the schematic in the back of your owner's manual shows where the signals go in and come out of these chips. If the reset and clock signals are working, the next step will be to check the Kickstart ROM chip select. This can be found on U6 in the Amiga 500 or U500 in the Amiga 2000. Pin number 12. Use the logic probe to check for activity or a pulsing action. A good indication of a problem with this line is it going high or going low and no change. The signal comes from Gary chip pin number 21, which decodes it from the 68000 address lines. If this signal is not there, you should check the 68000 and the Gary chip, as well as the Agnes chip. The 68,000 chip requires that the Kickstart ROM be located at memory location 0 on startup. The Kickstart ROM program starts out by moving its own memory location to F100,000 and placing the chip RAM at location 0. A control line called overlay performs this task. Overlay is generated by the 68,000 setting a bit 0 of peripheral data register A of the odd CIA low. That would be pin number 2 of U7 in the Amiga 500 or U300 in the Amiga 2000. To check this pin with your logic probe, put the probe on pin 2, then turn the power off and then on. At first, the probe will indicate a high state for a second. Then it will go low. At the same time, the screen will go dark gray from black. A common problem is the failure of the CIA chip. Since there are two 8520s on the PCB, you can try swapping the integrated circuits. If this fixes the problem, replace the defective 8520. This covers most problems related to a no screen indication. We will now cover the System I/O section. The 8520 CIA integrated circuits are the heart of the I/O section. They are used by the disk drive, keyboard, printer, and serial ports. The first step in troubleshooting this section of the computer is to check for the presence of the control line signals for these integrated circuits. The first signal we will check is the chip select on pin 23 of both of the CIA integrated circuits. The logic probe should indicate an active signal. Now check pins 19, 22, and 25. All should indicate active signals. If any of these signals are not active, check the 68,000 CPU, the Gary chip, or the 74LS32 IC, which decodes the IC selects for the 8520s. The 74LS32 will be U37 in the Amiga 500 or U302 in the Amiga 2000. The disk drives need to be working before anything else can be checked. Observing how the drive responds can tell quite a bit about what might be wrong. First, connect the drive data and power cables if you had removed them earlier. Make sure the drive has no disk inserted. Then turn the power on. The computer should go through its normal boot-up procedure. At some point in time, you should hear the disk drive making several clicking sounds, after which the workbench requester should be displayed on the screen. The disk drive activity LED should remain dark at this time, and you should hear a clicking sound coming from the disk drive once about every 2 seconds. If the workbench requester takes a long time or does not appear at all, the computer may not be addressing the drive correctly. Start with checking U7 in the Amiga 500 or U300 in the Amiga 2000 at pin number 21. Here you should see the probe flash once every 2 seconds. This should coincide with the clicking of the disk drive. This signal is an interrupt signal which is generated by the CIA to tell the computer to check the disk drives. Now check pins 13, 11, and 10 of the second CIA, U8 in the Amiga 500 or U301 in the Amiga 2000. If any of these signals are missing, try changing that IC. If the signals are good, check pin 4 of U7 or U300 in the 2000. This is the ready line coming from the disk drive. If this signal is missing, it may indicate a bad drive mechanism. The following checks require a blank disk with the write protect enabled. While inserting the disk in the drive, check pins 6 and 7 of U7 in the Amiga 500 or U300 in the Amiga 2000. Then check pin 17 of U8 in the Amiga 500 or U301 in the Amiga 2000. Finally, check pin 16 of the Paula chip. Check these pins while the drive is spinning. Failure of any of these signals indicates a defective CIA, Paula, Gary, or a possible problem on the Amiga motherboard itself. Now insert a formatted disk into the drive and check pin 37 of the Paula IC. While the disk is reading, you should see the probe flashing indicating an active signal. Check pins 5 and 6 of U7 in the Amiga 500 or U300 in the 2000. They should pulse every second or so even after the drive comes to a stop. If no signal is indicated, then most likely the drive mechanism is at fault. If the drive reads okay, but will not write to the disk, make the following checks. Insert a blank disk into the drive and set the computer to format the disk. Now check pins 38 and 39 of the Paula IC for signal activity. If they are okay, then check pins 44 and 45 of Gary. Then check pins 8 and 11 of the 74LS38 IC, which would be U36 in the Amiga 500 and U900 in the Amiga 2000. This is the disk drive write path from Paula to the drive mechanism. Check the signal from Paula through the various chips to the drive mechanism. If the signal stops somewhere, the chip prior to that in the circuit would be most likely the defective chip. Well, that covers most of the problems related to the disk drives. Remember that the 8520s, Gary, and Paula chip are all prime suspects anytime you have a drive problem. The Amiga keyboard is a computer in itself. The 6570 IC reads the key you press and converts that into a key code. This key code is sent serially to the input on pins 39 and 40 of the odd CIA, U7 on the 500 and U300 on the 2000. While pressing the keys on the keyboard, check these pins with the logic probe. They should flash anytime a key is pressed. The 6570 CPU has a built-in diagnostic. If there's a problem with the keyboard, the caps light will flash. On many Amiga 500 computers, the small printed circuit board will short out the shielding which covers the Amiga motherboard. The pins on the 6570 will cut through the plastic insulator on the back of the keyboard. This will cause the caps light to flash. Placing some electrical tape over the plastic may fix this problem. Keep in mind that any keyboard problems are most likely related to the keyboard itself. The 6570 IC is the most likely failure. Troubleshooting the serial and parallel ports is quite simple and only takes a few minutes. The serial port control lines are accessed by the even 8520 CIA, which is U8 on the Amiga 500 or U301 on the Amiga 2000. The Paula chip handles the serial data, and the 1488 and 1489 ICs convert the voltage levels from the 5-volt TTL levels to the plus and minus 12-volt RS-232 levels. The parallel printer is controlled by the two 8520s. Simply change the 8520s one at a time and test the port by trying to print something. If you find the chip is bad, replace it. Input from the two game ports are input to the Denise chip by way of a 74LS157 multiplexer IC. Try changing the Denise chip or the 74LS157. The 74LS157 is soldered on the board, so great care should be taken. Overall, the simplest way to check the I/O port's operation is to use a test software package such as Wilcom's Amiga Analyzer. The software uses test connectors to test the correct operation of all the ports. It will also tell you which signal line failed and the signal path it took. This can be an invaluable time saver. That pretty much wraps up the standard troubleshooting section. However, in this next section, we will show you a time-tested method used by professional technicians all over the world. If used correctly, it will diagnose a majority of the major common problems that occur in about half an hour, without any special tools or test equipment. We will call it the chip substitution method. In order to use it, you will need to have a spare parts kit, as described earlier in the video. Although the method is simple, there is a logical order of step you should follow. First, lay out the computer with the motherboard exposed. The system should be connected to a known good power supply and monitor with a good disk drive attached. Now turn the computer on and observe the power on indication as described earlier in the video. If a color is displayed, try changing the chips associated with that color. If changing the chip doesn't work, or the computer comes up with a totally blank, black, or white screen, turn the power off and replace all the questionable chips on the motherboard, which are in sockets, with the known good chips from your spare parts kit. Now turn the computer on. If the computer still does not come back on, then check the IC sockets for questionable contacts or bent pins on the ICs. Once all that has been verified as good, the problem can be assumed to be with one of the soldered on components of the motherboard. At that point, you can try to isolate the defective component using the standard method or take advantage of the motherboard service plan described earlier in the video. The good news is that in our experience repairing hundreds of Amiga computers, the most common failures are with one of the socketed ICs. That being the case, the screen should now be presenting you with the Amiga Workbench Requester. Now you can test the questionable chips by returning them to the computer one at a time, observing the results of the power on test as each chip is returned to the computer. At some point, the computer will display the offending symptom again. At that point, remove the chip from the computer and mark it as bad. Don't be surprised if more than one chip is bad. That is why it's important to replace all the socketed chips on the motherboard when you start testing it. We hope you'll find this video helpful in the repair of your computer. The information contained here has been collected over many years of servicing the Amiga computer. Have fun and good luck.